All right, so in the fourth lecture today, we're going to talk about bundle branch blocks. Now, being able to identify these is very important because a left bundle branch block is something that is treated like a heart attack a lot in emergent situations. And also because of the way they look, if you're new at interpreting them, they can be very intimidating and confusing. So we're going to take a look at these and just dive right in. So first of all, we're going to talk about what is a bundle branch block. A bundle branch block has to do with the pacemaker cells. So we're looking here at a very rudimentary map here of the pacemaker cells in the heart. And you'll notice here we've got the right bundle branch, of course, on the right side of the heart. So the right bundle branch encompasses this kind of pathway, if you will. All right, and the left bundle branch will incorporate this section right here. So one's on the right, one's on the left, very, very easy to tell between the two. Now, as the name implies, uh, what happens is one of these is going to be blocked, which means electricity is not going to be able to travel through the pacemaker cells for whatever reason. Okay. So, electricity is in most cases, of course, it's going to travel normally. SA node is going to come down internodal pathways, hit the AV node, hang out for a second, go down this bundle of His, and then it's going to get to this impasse. Now, let's say we have a left bundle branch block, which means electricity is cut off right here. So what's going to happen is electricity is going to flow down here, no problem, and the right ventricle is going to depolarize normally like it would, but because electricity can't travel through here, what's going to happen is the electricity from the right ventricle is going to work its way across to the left ventricle. Now, this process is very slow. The myocytes can conduct electricity, they're just not very good at it. And so, what that means is it's very slow and it's very wide. So, the QRS on these are going to be very wide because the wave of depolarization is slowed down a little bit. So, now let's take a look here a little bit more into the left bundle branch. The same is true here. Electricity will travel through the left bundle branch. It's going to spread into the left anterior fascicle and then the left posterior fascicle, which we'll talk more about later in hemi blocks. But again, if there is a right bundle branch block, then electricity will travel through here and then slowly work its way into the right ventricle, again, creating a wide QRS. And one other thing to note here is, let's say, for example, both bundle branch blocks or both branches are blocked. Well, then I don't have a bundle branch block anymore. What I have is a complete heart block. Okay. So a third degree heart block if that occurs. So there's no more, it's no situation in which both bundle branches are going to be blocked and we're going to call it a bundle branch block anymore. We're going to have a different kind of problem there. So let's take a look kind of at the more important one is the left bundle branch block first. So here's our EKG. Now, the criteria, of course, as we kind of mentioned and implied in the last one, is because the electricity travels very slow, I should see a wide QRS in all of the leads. Okay. So again, wide QRS, 0.12 seconds or 3 little blocks wide. I've got a wide QRS right here. It's wide here. It's wide there. It's going to be wide pretty much everywhere you look. That's criteria number one. That's the most notable one. Okay. It's not a ventricular beat. Ventricular beats are wide, but because the SA node and the internodal pathways and AV nodes are still functioning, then this isn't a ventricular beat. It's a little bit different. Okay. Now, second off, what I'm going to do is I'm going to look at 3 different leads, and that's all that I'm going to look at. You can kind of ignore the rest for this criteria. I just want to focus in on these leads, to make your life simpler. The next thing I want to look at here is a monophasic R wave in lead 1. Monophasic R wave in lead 1. So I'm going to look right here, try to find a better color. There you go, this one pops. So I'm going to look in lead 1 right here. And to be monophasic means that I'm only going on one side of the isoelectric line. Like I'm only going in one direction. I may not be on one side of the isoelectric line per se, but I'm going in one direction. So you start with your QRS, draw your isoelectric line kind of all the way through. And what you'll notice that this is an R wave because I only have an upward deflection, okay? And that upward deflection ends right here. This is where we would count the J point to be. And this upward deflection, I don't have a downward deflection, so I don't have a Q wave, I don't have an S wave or anything like that. Just this R wave. Even though it goes below the isoelectric line, I'm only going up, I'm not going down and up, if that makes sense. So monophasic R wave in lead 1, I have that here. And then I'm going to look at V1. Okay, so we're going to draw your attention right here, V1, and I'm looking for a QS or an RS in V1. So again, why QRS? Starting at the very beginning of the QRS, drawing that isoelectric line right along here, a QS wave, if you guys remember from way back when, is a QRS. If this is the isoelectric line, goes down, back up, and ends. And that's it. That's a QS wave. You can have some elevation to it, whatever, but that would be defined as a QS wave because I only have a downward deflection. I don't have an upward deflection at all. And an RS wave is where I do have a deflection a little bit, but then it comes back down and ends with an S wave. Okay, that ends with an S wave. So if I'm looking at what I've got here, I've got a tiny little R wave and then big, very prominent S wave that ends above the isoelectric line right there. That is an RS wave. Now, one of the shortcuts you'll read about a lot, especially in like emergency medicine books, is the turn signal shortcut. This is using the J point. Okay, once you find the J point, I look back at the QRS. If I go down, then it's going to be a left bundle branch block. So you imagine like your car, and when you're driving, you hit the turn signal down. That is a left turn. And so because from the J point going backwards, I go down, it's a left bundle branch block. Okay, so that's one of kind of the shortcuts you can use to remember that. And then lastly, I'm going to look at V6, so which this has me looking, right here. I'm looking at a 0.04 second peak to the R wave in V5 through V6. So that means I'm one tiny block. It takes me one tiny block widthwise to get to the peak or more of the R wave. Now, this criteria, 9 times out of 10, really hard to see, very finite, not usually what I'm going to hang my hat on here. Most of the time in the truck emergency situations, I'm looking monophasic R waves in lead 1, and I'm looking for that QS RS in V1. Those and of course a wide QRS. Got to have the wide QRS. Get those 3. That's usually good enough to call it. But just for technicalities, that is the kind of final criteria on that left bundle branch block. And it should be noted that if you have a left bundle branch block and it is a new onset in the patient, then that is a STEMI criteria. So you are activating the STEMI as if they had ST elevation in 2 or more contiguous leads. And note here that this patient does have elevation in 2 or more contiguous leads right here. So now it's a little bit different. ST elevation, in the previous videos we talked about is bad, if you have it in these contiguous leads, but that's a normal thing in left bundle branch blocks. Like you're going to see ST elevation in these leads. It's not uncommon to see that. We're going to talk more about later, kind of interpreting what's there and what's not. But moving on to the right bundle branch block, in this criteria, if you couldn't already figure it out, first one's going to be wide QRSs. And I'm looking at all the leads, and that's what I've got. I've got wide QRSs here all throughout. Now, I know sometimes, especially for beginners, let's say we're like looking right here, and you're like, well, where does the QRS end? Does it end like right here, or does it end like right there, or where does it end? And again, back in earlier videos, I mentioned this thing that remember that on the Life Pack 15s, at least I can vouch for, this column is all the same moment in time. So if you have trouble figuring out where the end of the QRS is in these, you can go ahead and look at these and then figure out, oh yeah, well, looks to be right here because I have a very sharp change in angle right there. So that's where the end of my QRS is, right there. So wide QRS, got to have it. Second of all, oh, look, we're going to look in the exact same leads as we did before. Okay, lead 1, V1, and V6 for the rest of these criteria. So super simple, right? Now, what we're going to do is we're going to look at V1 first. And much like in the left bundle branch block, I'm looking for a very specific wave morphology here. I am looking for a QR or R wave in V1. So I want a QR wave, which I have here. It starts with a Q, ends in an R wave right here. So QR wave, or just an R wave, which again, that would just be this upward deflection, and that would be it. Okay. Now, same kind of shortcut with the car thing that we talked about in the left one. Starting at the J point, I look what happens before, except, in the left bundle branch, I went down. This one goes up. So if it goes up like you would taking a turn in the car, if you do the right turn signal on, then there you have a right bundle branch block. It's one of the shortcuts there that you can use. Now, that's just one of the criteria there. If you really want to lock this in, I'm also going to look for slurred S waves in 1 and V6. Now, a slurred S wave, okay, is usually an R wave first, and then we have an S wave, and the S wave is going to take its time coming back up. So to kind of illustrate a little bit easier, normal normal RS wave right here, a slurred S wave is going to look something along the lines of like this, where it kind of like takes its time to get back up there. A lot easier to see in lead 1 than it is in V6 here, but it's still present here, and that's going to be your other criteria. You have those two things. You have the wide QRS, you got the QR or R wave in V1, and the slurred S wave in lead 1 and V6, then you've got a right bundle branch block. I will note, don't be fooled by bunny ears in V1. What are bunny ears is something that looks like this. Bunny ears is what they call it. It's kind of an R prime wave. You do see those frequently with right bundle branch blocks, but that's not a guarantee. So don't just say, oh, it's got bunny ears. We've got, right bundle branch block. Be vigilant, okay? You can see this one doesn't have bunny ears, and it's a right bundle branch block. So just kind of put that on your mind there. Now, moving along, we're going to talk about pacemakers. Way back when, they used to say that putting a 12 lead on somebody with a pacemaker was useless. That is kind of gone out the window a little bit in a video that we'll talk about later as to why. There's still a lot of information you can extrapolate from a 12 lead with somebody with a pacemaker. And so looking at here, you will normally see arrows. That's kind of one of your biggest signs that, oh, this person's got a 12 lead. I'm sorry, it's got a pacemaker on them. And what this is marking the pacer spikes, which kind of brings me to the first criteria right here. Anytime that the pacemaker fires off, okay, you're going to see these little arrows. And these are called spikes, these pacer spikes. Pacer spikes are generally less than 2 milliseconds in duration. So, like super narrow, they usually look something like just pretty much like a straight line, and that's it. Although that's not a straight line, I tried. It's a mouse. But oftentimes in the real world, you don't even see them. So, like, there's no very clear pacer spike here. You can look all day, but you don't see it. But what I do see is the arrows, and that's what I'm going to use to determine, like, oh, this person's got a pacemaker on. Um, and there's different types of pacemakers. There's atrial pacemakers, ventricular ones, both demand pacing, which is only used when they need it. So there's all sorts of pacemakers, but either way, you see it, you see that arrow in front. Now, morphology here on the pacemakers looks a lot like a left bundle branch block. You've got a wide QRS right here. There's normally some elevation here, ST elevation. You have a discordant T wave, which means the T wave goes the opposite direction as the QRS. That's what discordant means. And we're going to talk about more of that in the next video as well. But discordant T wave is normal for a pacemaker and a left bundle branch block for that matter. So that's why it says should be discordant right here. Should be discordant. So that's the general layout of what a pacemaker is, or what a pacemaker looks like. But I want to draw your attention to this 12 lead too to kind of illustrate some points here. This person is on a pacemaker, okay, and you can see here that there is a pacer marker, pacer spike, followed by a ventricular beat. So this person's ventricles are being paced, okay, and you see that consistently throughout. But what you see also here is these with no arrow. There's just no arrow. There's no pacer spike going on right here. So what's happening here? Okay. What's happening here is that this person's heart is beating on its own. Okay. It's taking some initiative, if you will, and firing off at random times. Now, this can be a dangerous thing, especially if you time it wrong. You can go into a lethal dysrhythmia, which again, that's a lot of work and bad for the patient. So not a direction you want to travel in. So look at this right here. So let's take a look at V4, V5, V6. It's very prominent. How do you tell the difference between their heartbeat and the pacer? Well, because I follow these pacer spikes, pacer spikes aside, because the electricity is traveling in the same direction every time, like the same way every time, the same path, if you will, the morphology is going to look the same. Okay. But what I have here is a completely different morphology. So that means the electricity has traveled a different pathway than previously or than otherwise. And so I know that has a different origin. That beat originates somewhere else. And in this case, it originates in the ventricles because it's wide, it's discordant. That's what a PVC looks like. So just so you know. Now, that's a kind of a brief overview on bundle branch blocks and pacemakers. And in the next video, to build the tension a little bit, we're going to be able to look at criteria that we can use to determine if, with high likelihood, if a person is having a heart attack in the presence of these things. So very exciting. Super stoked for that one.